Okay, so in this video, we're going to try to work out everything you need to be able to sketch a phasor diagram and a power triangle. So a phasor diagram, if you remember, should have VR, VL, VS, and your current. So you should have these voltages and that supply current as well. So looking at that, the things we still need to find out are VS and VL. Because we already have a value for VR, that would go on your phasor diagram. Your current, I, that would go on your phasor diagram as well. So, looking at this, we should be able to work out VL because we know the current coming from here is 2 amps and we've got a value of XL as being 30 ohms. So for the inductor, the impedance of the inductor is equal to the XL. So VL is going to be I times XL. So 2 times 30 gets you 60 volts. Now you also know that VS will be the phasor addition of that. Let me show you what I mean. So the phasor addition you're going to do on a phasor diagram. So let's start sketching out our phasor diagram. Draw it quite big. And I know that the directions that I draw my phasors in is standard. So it doesn't change from one phasor diagram to the next. So my current 2 amps. So for my current scale, I'll say 1 centimetre is 2 amps. Current always goes in the same direction as well. So 1 centimetre equals 2 amps. Then that is my current phasor in there, matching up with that. Then when I look at my voltage phasors, I know my VR is in phase with my I. So I'll pick from a scale this time, 1 centimetre equals, say, 10 volts or 20 volts. 20 volts. 1 centimetre equals 20 volts. So my voltage across my resistor, and I'm on 1 centimetre equals 20 volts, I've got 100 volts there. Okay. And I know it's in phase with my current phasor. So that would be my VR phasor there. I'll go over this in a pen that works a bit better. That's my voltage across my resistor. If you remember, the voltage across your inductor goes straight up the way. So I've worked that out to be 60. So on my scale of 20 volts, that'll be 3 centimetres, 20, 40, 60. That's my VL. And to get my VS, it's a phasor addition of VR and VL. So I'm essentially taking that VL phasor, putting it on the end of VR, as if it's over here. And then I'm working out what it is from here to here. And that phasor there, that is my VS. And that's my circuit phase angle. So by measurement, my VS on my scale of 1 centimetre equals 20 volts. My VS is about 6 centimetres. So 6 centimetres, and each one is 20. so 120 volts. And my circuit phase angle, measured with my protractor, centre that on my phasor diagram, and it pretty much looks as if it's right on 30 degrees. So my circuit phase angle, 30 degrees. That's my phasor diagram done. But looking at this, let's check. So if I use Pythagoras' theorem, to get Vs, I should be able to do the square root of VR squared plus VL squared. It's a right angle triangle. There's the right angle there. So that should work. Now I'm not expecting it to be exactly the same. But it should be quite close. Let's find out. So I've got 100 squared plus 30 squared equals, and then I'm going to do the root of that answer equals. And it's come out as being 104.4 volts, which is quite similar. Oh, hang on. 100 squared, 30 squared, root my answer equals. So now it should, for VL, it should be 60, that value there. So 100 squared plus 60 squared. So 100 squared, 60 squared. Then root of that answer, hopefully this will be a bit more like it, 116.6 volts. So let's compare that, 116.6 over here, and I'm comparing that to that. It's not too far off. You would expect there to be a difference because one is measured from a sketch and the other one is calculated. For my angle, I'm going to use trigonometry. So on the basis that tan of an angle is the opposite, which is that, VL, over the adjacent, which is this one here. Then my angle itself must be the inverse tan, or tan to the minus 1. VL, 60, definitely, divided by VR, up there 100. My angle, I'm expecting to be 30 degrees, but let's find out. So I'm going to do shift, tan. So I've got the tan to the minus 1 pops up there. 60 divided by 100, and close my brackets. And I've got 30.96 degrees. So 30.96 degrees. 30.96 looks quite similar to that. So 1 degree of difference. That's not bad. So that's me worked out everything I need for my phasor diagram. That's my phasor diagram there. Remember the things that you need in your phasor diagram. In your phasor diagram, you should have your current, voltage across your resistor to scale, voltage across your inductor to scale, and your supply voltage, all to scale. The next thing to do is to work out, for the circuit, the power triangle. And on the power triangle, you should have true power, apparent power, and reactive power. So that's what we're going to work out next. And to work out your powers, you need to know what the voltage is, the VS, 116.6 volts. That's from our answers earlier on, 116.6. You need to know what your supply current is, 2 amps, and you need to know your phase angle. So the 2 amps has come straight from the circuit diagram, and the phase angle will be that 30.96. We'll use the calculated answer so it's more accurate. Next thing you're going to do is you're going to write down your 3 power formulas. So true power, P equals VI cos of the angle. Then you've got your reactive power, Q, VI sine of the angle. And your apparent power, S, just V times I. So starting with true power, P equals VI cos of the angle. So it's 116.6 times 2 times cos of 30.96 degrees. That's the first one. I'll clear that down. So it's going to be 116.6 times 2 times cos of 30.96. That gets me 199.98 watts. So true power is measured in watts. My next one. The same V, the same I, but this time it's sine of the same angle. So 116.6 times 2 times sine of 30.96. And that's 119.97. Now Q isn't measured in watts, it's measured in volts, amps, reactive, VAR. And S, your last one, the same 116.2 and the same value for current. So that gets you 232.4 volts, amps, VA. Probably the trickiest part now is to choose your scale, what scale you want to have. Say we went for a centimetre equals 40. So then for our true power, we're going to pick a starting point. Go for here. So our true power was 199.98, and we'll divide that by 40 to get what it should be in centimetres. 4.9995, so pretty much 5 centimetres. And your P is always on your horizontal. Then my Q, 119.97. 2.999, so pretty much 3 centimetres. That's my Q. And to make sure I'm correct, I'm going to measure this one on my scale and see if it ties in. So I think that's about 5.7, 5.8 centimetres. So let's have a look. On my scale, 5.7 times 40, 228, 232, that's not bad. So if I was doing 232.4, dividing that by 40, it should be 5.8 centimetres. It's not far away from that. And my angle in here should be the same as my circuit phase angle from before. It should be 30.96 degrees, so it should be about 31 degrees. Let's have a look. Yeah, it looks just under 31 degrees. So that's fine. So there's my P, my Q, my S, and my angle. So that's my power triangle done, and everything I need for it. And my phasor diagram done, with everything I need for that.